Welcome to another Mr. Paul video. In this video, we're talking about 4.3, graphing non-proportional relationships. That's a fancy math way of saying we're going to be graphing things that either don't go through the center or are not straight lines. For our purpose, we're only going to be worrying about the lines that don't go through the center. We are going to be graphing straight lines, just ones that don't go through the center. So let's first look at a non-proportional relationship. Okay, we've seen a couple of these in the past. Y equals 2x minus 1. 2x minus 1. This is an example of a non-proportional relationship. So x and y are related in a unique way, and we want to see some samples of how those are related. So let's make a table. We have x and y, and we want to know how they're related. So let's make a table and get a couple of samples of what our line looks like. Well, let's choose some numbers on top that we like. Numbers that we know we're going to have to multiply by 2. So choose nice and easy numbers. 0 is one of those numbers. 1, 2, maybe a -1. Well, let's think about this for a second. Let's start with the easy numbers to multiply. If x is 0, let's make a chart here, a t-chart, that helps us keep organized. Here's x's, here's y's, here's how y is related to x, 2x minus 1. So when x is -1, when x is 0, when x is 1, and x is 2. When x is -1, it's saying 2 times -1 minus 1. When x is 0, it's like saying 2 times 0 take away 1. When x is 1, it's like saying 2 times 1 take away 1. And when x is 2, it's like saying 2 times 2 take away 1. So what are these values? How exactly are these related? Well, 2 times -1, as in when x is -1, 2 times -1 is -2. -2 take away 1 more is -3. 2 times 0 is 0. Well, 2 times 0 is 0. Take away 1 from 0 is -1. 2 times 1 is 2. 2 take away 1 is 1. And then 2 times 2 is 4. 4 take away 1 is 3. So when x is -1, y is -3. So I can put a -3 here. I know it's -3 because I did the math. When x is 0, y is -1. When x is 1, y is 1. And then when x is 2, y is 3. These are samples, little snapshots of what my line looks like. So if I was to sketch a graph of this line, I can use these points to kind of give me an idea of what the line looks like. So I can go make a couple of dashes here to kind of give me a point of reference. When x is -1, y is -3. When x is -1, remember this is the negative x direction, the positive x direction, the positive y direction, the negative y direction. I'm going to go x is -1, y is -3. So x is -1, y is -3. So it's going to be somewhere down here. When x is 0, y is -1. When x is 0, y is -1. So I'm going to go right there. When x is 1, y is 1. So it's a line somewhere right there, or a dot somewhere right there. And then when x is 2, y is 3. When x is 2, y is 3. It's going to be somewhere right there. If you'll notice, it starts to make a line. Now, my line isn't the best at the moment, but it's a good sketch to give me an idea of what my line would look like. It would look something like this. All of this table and graph and the t-chart, they're all talking about the same information. It's a way of relating two separate numbers like x and y in a very unique way. These are just samples along this line, but remember, anything along this line could also have been in the table. This line is made up of infinitely many points that are really, really close together, and we just connect it to say it's anything Anything on this line is related in that way. Okay. Well, let's do another example. Let me first erase this, and we'll do another example where x and y are related in a unique way. But this time, we're going to use some fractions. So let's see what we got. Let's take the example of y equals 1/2 x plus 3. Y equals 1/2 x plus 3. Well, let's make a table. Let's see what some of these samples look like. We have x's and y's, and we're going to get a couple of little snapshots, a couple of little pictures on what this line might look like. If I know little pieces of it, I know what the whole line will probably look like. And I'm going to choose numbers for x that I like to multiply by 1/2. I always like multiplying 0 because I know what 0 times anything is, but I don't want to choose the number 1 because 1 times 1/2 is 1/2, and then I have to still deal with fractions. If I choose numbers that help me eliminate fractions, I'm in a better situation. So maybe if I chose the numbers 2 and 4, because I know when I take half of those, I'm still left with whole numbers. And maybe I'll choose -2 because I like to see some negative values. Well, let's think about the positive numbers for a second and make our t-chart that looks something like this. We have x's and y's, and they're related in this way. Y equals 1/2 x plus 3. Well, we had -2, 0, 2, and 4. That means that 1/2 times 2 plus 3, 1/2 times 0 plus 3, 1/2 times 2 plus 3, and 1/2 times 4 plus 3. So what do these values equal? Let's do the math real quick. 2, half of that. So half of 2 is 1. So this part's 1. So 1 plus 3 is 4. Excuse me, I made a mistake. Let's remember, this is -2. -2, let's be clear. Okay, this is -2. I caught my mistake early. Don't punish me. I caught my mistake. This is a -2. So 2 times 1/2 is 1, but -2 times 1/2 is -1. -1 plus 3 is 2. 0 times 1/2 is 0. This part's 0. 0 plus 3 is 3. 2, the positive version this time. 2 times 1/2. So half of 2 is 1. 1 plus 3 is 4. And then half of 4 is 2. 2 plus 3 is 5. So what this means is when x is -2, y is 2. When x is 0, y is 3. When x is 2, y is 4. And when x is 4, y is 5. I have little snapshots of what my line would look like, little pieces, little samples of what that line looks like. So let's graph it. Three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I have no idea why I count every time I do that. I have no idea why. I just do it. Okay. When x is -2, y is +2. So when x is -2, y is +2. So there's 1 right there. When x is 0, y is 3. When x is 0, y is 3. When x is 2, y is 4. When x is 2, y is 4. And when x is 4, y is 5. So when x is 4, y is 5. You'll notice it starts to make a line. With each of these spots being samples, little pictures on my line. But remember, anything on my line is also a value I could have chosen. It's not to say that only these values I picked are on the line. Everything's on that line. Could be something I could have been in the table. Remember, we're talking about the same information. Now, I know what you're thinking. This is a bunch of work. This is a lot of work. Just to see how two things are related? What? Mathematicians were thinking the exact same way that you are right now. That's a lot of writing. Perhaps there's an easier way. Maybe there's an easier way. So let's talk about the easier way. Let's talk about what mathematicians discovered, and it actually requires no math. So let's erase this for a moment. And let's go back to our original example, where we had y is equal to 2x minus 1. Y is equal to 2x minus 1. This was the first example we did in this video. And then we're going to think about y equals mx plus b, where the m, which was closest to our x, was the slope. And the number next to the b, which the number that was all by itself was the b, that was our y-intercept. The slope has components like rise over run. It's a fraction, where the top part of the fraction is our rise and the bottom part is our run. The y-intercept looks like b equals some number, or 0, comma b. We're going to use this information to help us graph, and it's going to require no math. No calculations. I should say no calculations. Well, let's think about it. If my m is my slope, this is my slope. This is my y-intercept. We learned this yesterday in the previous videos. Well, the slope has a rise and a run, which means the slope is 2, sure, but 2 over 1, with the 2 being the rise and the 1 being the run. And then my y-intercept is b equals, sure, but it's also 0, comma b, meaning 0, comma negative 1. This is my y-intercept. So how does this help us graph? Let's draw another sketch of a graph here. The same tick marks here. If I start with my y-intercept, I know 1 point already. And that's at 0, comma negative 1. I know 1 point on my line because that's where my y-intercept is. I'm now going to follow my rise and my run to find additional points. Remember, the 2 over 1 is a rate. It's the rate to where it is rising and falling. It's the rate between the 2 points, the 3 points, the 4 points. So from my y-intercept, I'm going to count up 2, because this is a positive rise, and I'm going to count over positive direction 1, because that's my run. So I'm going to climb up 2 over 1 and make another point. I'm going to climb up 2 and over 1 to make another point. I'm going to climb up 2 over 1 to make another point. Up 2 over 1 to make another point. You'll see how it starts to form a line. This new line is not actually new. It's the same line that we did with the very first example. We just did it in a different way. Knowing our information about slope and knowing our information about the y-intercept, we didn't have to do any math. I shouldn't say that. We didn't have to do any calculations. We did have to understand what slope was and what our y-intercept was. Okay, well, let's look at the other example that we did. Let me erase this here. The other example that we did was y equals 1/2 x plus 3. Well, the 3 is going to still be my y-intercept, and the 1/2 is going to be my slope. That means that 1/2, with 1 being the rise, and the 2 being the run, and my y-intercept is going to look like 0, 3. So if I want to graph this, let me make my axis right here. Make some tick marks. I'm going to first give me some steps. I'm going to first start graphing y-intercept, meaning I know 1 point already. 1 point, that's my y-intercept. So this line, whatever it looks like, has to cross at 0, 3. So 0, 3. There's 1 point on my graph. Next, I'm going to follow the slope. Follow slope, meaning rise, then run. Okay, so what this means is I'm going to find additional points by rising and then running from a point that I already know. Meaning I'm going to rise 1 and run 2 to find additional points. If that's how they're related, I can start at the y-intercept and then rise 1 and then run 2. Wherever I stop is another location of a point. I'm going to rise 1, run 2. There's another point. Rise 1, run 2. There's another point. Rise 1, run 2. There's another point. You'll notice it starts to make a line. If you want to compare lines, I can draw better than that. Compare lines to the ones that we drew using the table. You can. You'll find that they're the exact same line. But we didn't have to do as many steps. We didn't have to do as much math. So our last step should be connect the plotted points. We have a way of making a table. We now have a second way of graphing these non-proportional relationships, and that's involving our knowledge of the slope and the y-intercept. That's all for today's video. I hope you guys have a great weekend, because today, when you're seeing this video, if you're watching it the day I'm making it, it is a Friday.